Hello again, a new day, the same project, I'm trying to build myself a linear power supply. Okay, let's talk about this, There are a lot of, let's call it simpler booster buck converters, switch power supplies. But when you are working with audio stuff, like preamps or tone control, equalizers, anything related to audio, I'm talking about the analog part of the things. One of those power supplies, switching power supply, it makes a lot of problems, make a lot of troubles because they have all kind of harmonic stuffs, harmonic signals, and have all kind of radiations, signals, and everything goes into the signal path, and that matters. It's noisy. In this situation, the most important thing is to have a power supply as clean as possible. And the linear classic, let's call it classic power supply, it's the best ever. I found this kit, it's working great, I tested, and I have no doubts it will do a really, really great job. Looking through my stuffs for a suitable transformer, I couldn't find anything, but this is from an audio amplifier. It's a kind of a line to low impedance amplifier. I mean, we apply 100 volts of audio signal at the input, and then we have 4 ohms, 8 ohms, and 16 ohms. Okay, so this is a kind of adapter from PA kind of line loudspeakers to normal 4, 8, 16 ohms something cabinet. You see, it's heavy, it's solid, and I think this will make a great transformer. Maybe you'll think I'm crazy. This guy is starting to wind, his own transformer. Yes, I'll do that. You know why? Because I'm pretty sure I can make a better job than the shops, There are a lot of formula for having your mathematics about transformers, and I can build this with a large specification, so it's not getting hot. It's working in a very nice magnetic, constitution field. I think it should be easy to take all this iron stuffs, E and I stuffs out of this, and then it shouldn't be a problem to wind this because we already have everything necessary. This is a plastic case, so shouldn't be a problem. Few hours of working. And why not? When I did that last time, I think it was like 30 years ago or something. So let me have fun. Let's go down in the magazine and let's take this guy apart. Let's try to get this guy dismantled. Okay, we're gonna have a lot of noise because my solar inverter is working big time. You see, outside it's a really nice weather. Let me show you. Sunny, but cold. It's the perfect time for having solar production. And let's see what we can do here. So first, we need to take these screws out. This was a professional transformer. I can tell you that, far better than any kind of shop. I don't want to name it. There we go, people, job done. We have to go to the next phase, and the next phase is, of course, getting the wires out from this. Maybe I can reuse this wire. I bet this is one of the best. Okay, so here we are. This is the coil, and we have to start doing some mathematics here. We have to figure the transformer calculation, number of turns per volts, and of course all these numbers necessary. And okay, so first we have to determine the core, and the area of the core is very simple to find. We have to measure this here, which is 28.3, and like that, which is 42.3, But I'll consider a 28.3 with 42, and that gives me, with tolerance, around 11.5 centimeters. Then we can find very easy the maximum power this transformer can sustain. That's very easy because the power is the measure of the core times 2. And that means around 132 watts. That's more than enough. And then, very easy, we can find the necessary turns per volt, because we have a generic formula of 42, that's a constant, divided by the core, 11.5, and that gives like 3.65 turns per volt. We need to find the size of the wires. Okay, so let's start finding the secondary wire gauge. I need 24 volts with around 5 amps, almost the maximum power supported by the transformer, like 120 watts. Let's see which of these wires is supporting 5 amps. Gauge 16, that gives me 5.2 amps, or better said, 1.29 millimeters diameter. Of course I can find that, but I'm pretty sure I can find 1.5 easily. So 1.5 will give me even more, 6.6 amps, even 7 amps. That's for the secondary, and we can do like that, 3.65, that's turns per volt, times 24. So the secondary for 24 volts will have around 87.6 turns. Okay, now let's find how many turns we need for primary, and that's 3.65 times 230 volts, that's 839.5 turns. And the last thing we have to figure is what kind of wire do we need for the primary. We can find that very easy dividing the power to the voltage, and we have 132 watts divided by 230 volts, and that gives me 0.57 amps for the primary. And if we check these numbers here, 0.57, 0.506, okay, we can use 0.4 to 0.45. This is done by hand, let's call it. But in the meantime, I found a really interesting software. Okay, there we are. And here, simply, we can add some numbers. Add. Let's have the dimensions of the core. Here is 28 by 42, and that gives me 138 watts. Here I have 24 volts, 5000 milliamps, or that's 5 amps. And let's calculate this, and there we are, people, and we have pretty close numbers. You know this calculator, thank you Silvio Clays. The primary amps, it's the same, 0.57. If I'm dividing 138 by 230, that gives me 0.6, exactly like there. But I believe 934 it will be absolutely okay with 0.5 or 0.45. That should be more than enough. And here we have the coil. Like I told you, this was a line transformer for audio amplifiers. I'm trying to dismantle this as nice as possible, and I want to reuse all the wire. And I believe the primary is already half done, because we had 100 volts input to this transformer. Let's see about the gauge here, which is 0.5, almost like the one we need. Okay, so here we are with the support ready for the new coil. Unfortunately, I couldn't use any of the old one, even if the wire was the same, the right dimension, I may call it, because the line audio transformer. It was a kind of, all the coils, the primary and the secondary was mixed. I couldn't use any of them. But anyway, it doesn't matter, it's clean, so I can start a brand new one these days.